Hello everyone, my dear learners, my channel visitors. Today I wanted to cover quite important topic. I think I missed it. It's about exceptions in Python. So I encourage everyone, please, when you visit my channel, try to get a big picture. Don't just watch those short lessons, but they combined. All the lessons belong to certain books or playlist in YouTube. We call the combination of tutorials playlist, so in a way it's a book. So if you learn Python, for example, you should start from Python fundamentals book, maybe 12, 13 lessons. Then you should try Python OOP, maybe another 8 or 9 lessons. And the third book about Python is called GUI apps. So it should be read after you watch the first, or you read the first two books. But what I realized recently when I was working on Python fundamentals, I missed one thing which is definitely fundamentals, and it is called exceptions. Exceptions are basically everywhere. You shouldn't be afraid of them. You just have to know how to deal with them. Exceptions are abnormal situations, serious errors. The program usually crashes after the exception is raised, or sometimes we call it thrown. So let's talk about it. Today I'm going to discuss exceptions at the very basic level. But maybe later I'm going to record another lesson on exceptions, because the point is you can just use system exceptions. You just can understand or learn how to deal with them, or you can create your own exceptions, or you can raise your own exceptions, your own errors if something happens in your program logic. And that's, I would say, a second level of knowledge, because now if you're interested to do exceptions yourself, you have to understand a little bit object-oriented concepts. So today we're just talking about how to deal with the built-in exceptions, and there are many. So Python engine or Python interpreter can raise a lot of system errors, unexpected situations, and all of them, all those system or built-in exceptions, they have standard names. I can show you from W3 schools. And W3 schools, a list of some. It's not the whole list, but it's some system exceptions, and all they have standard names. Okay, let's get practical. So let's say I do something super simple. I create an app to add two numbers. You see, it's so straightforward, so easy. I get string in line 7. I convert it to integer, and then I do the same with the second number, line 10 and 11. Then I add, then I print the result. So let's see how it's working. Super simple. You see the adder, my app does what it's supposed to do. But if user just made a mistake, we all humans, it doesn't have to be on purpose. We all humans, we all may not understand the program help. We all may just press the wrong key on the keyboard. So if it happens, if let's say instead of 1, I type Q1 or just Q, that's the exception. So that's the abnormal situation. Python didn't know what to do, how to convert letter Q into integer number. So Python engine raised an exception. The name of the exception, by the way, value arrow. Remember, any exception in Python has a name. And you see explanation, invalid parameter for casting function. We covered casting in our course when we were discussing types. So, and also Python engine shows me where the exception was raised. Sometimes we call it thrown. And it was at line 8. So program started normally, but then all of a sudden user didn't provide right number. Program crashed. So sometimes we call it throw and catch. We sometimes use this terminology talking about exceptions. System can throw exceptions and programmer may catch or handle or process them. If you don't catch as a programmer, that's what happens. So obviously I want to protect my program. Obviously I want to make it more reliable. I may validate, of course. Maybe that's the first or straightforward idea which comes to anybody's mind, even you're not aware about exceptions. So the first idea, the first solution would be, okay, let's validate, let's check the user's input, and let's not call int if we're not sure the characters are good. So that's the first or straightforward approach. Okay, if this line is risky, if this line may crash, why don't I check my characters before I do the casting? So the format is pretty simple. For integer numbers, the first character may be plus or minus, and the other characters are digits. So it doesn't look like a big challenge to validate such a string where the first character could be plus or minus and the rest is just digits. So what I did, I created another version of my adder, and because I accept numbers twice, it makes sense, of course, to put validation code into separate functions so I can reuse it twice. So what I did, I created function, it's called goodInt. It takes a string and it returns an empty string if the string is not good, and it returns numeric string if the string was good. You may ask, why don't I return just an integer number as a result of my function? The problem is somehow I have to return good values and bad values. So bad value would be an empty string, good value would be a number but as a string. Because if I return integers, then any number basically can be the result. I don't technically have a space to return a special integer number to signify it was an arrow. So the logic is empty input is bad. I return immediately empty string, arrow, message is returned. Then I create another string and I'm checking the first character of my input, and if, because it's not necessarily my input has plus and minus. They may be there, but they don't have to. So I just remove the first character. So this is quite useful expression in Python if you want to take substring from 2. So you can provide here two numbers from 2. If you don't provide 2, that means to the end of the string. So I extract from my input everything except first character, and I save it in signed removed string. Then I check signed removed if all the characters are digits. So I'm using library function. I don't do everything from scratch. I still rely on Python library function is digit. It's checking if all the characters are digits. So if they good, if all the characters are digit, I return now everything my user typed. And it's a good number. It may have plus, it may have minus, but not necessarily. If there is no numeric symbol, I return empty string. So that's a validator. So it takes the string, the user's input, and it returns us a good integer number, but as a string, and empty string as an arrow. And then I can just rely on my string. So you see, I now check, I validate. By the way, this is Python style. Sometimes in order to make function calls easier to understand, you provide parameters names. So this way functions calls are more self-explanatory. So I do not do casting if I'm not sure my string is good. Only if my string is good, I do the casting, I break out of the loop. So I put two numbers input in a loop. And if the input is not good, well, I print a message and I repeat again the same attempt user going to type again. The same for number 2. Let's run it. Now my program shouldn't crash, should be more reliable. Let's try an empty string. Let's try a bad string. Let's try a good string. And here we are. You see, it's working. So my program definitely now is more protected, more reliable. It's not going to confuse the user because it's very bad. It's very bad if your program crashes. Users are upset and they may complain, they may not buy. So I fixed the issue. I provide a validator for my input. Then here I start the main program, and altogether it's now 36 lines, so it's much longer than it was before. Why? Because any service comes with a certain price. But there is an easier solution, and it is now about exceptions. So let's open another version of my adder, and now we can talk about exceptions. So exception is extraordinary situation, and I know ahead of time when I start programming, this is a risky function. This function may raise an exception. So technically speaking, if you see such a situation when you have lines or block which is risky, dangerous, you put it into try except statement. So let's take a look how you deal with the exceptions. You need a new statement, try except. So try is the lines that may throw an exception. Except block is the lines where you handle your exception. You do something about it, otherwise if you don't catch, you don't handle, the crash going to happen. So if something bad happens here, I'm going to this block, but if this block was fine, no exceptions, then this part is skipped. So it's kind of try except statement, kind of similar to if else logic. Let me show you how it's working, try except statement. So if something happened during the try block, you execute everything after except. If nothing happened in the try block, you proceed straight to the line after try except. So you see it's kind of similar to if statement, but of course maybe if statement is simpler because you have here just a condition, but block it's vaguer. So the logic is vaguer because if it's big, if this block is big, it's sometimes hard to tell exactly what line was interrupted, where, at what line the exception happened. Okay, now, what I did, I applied now my knowledge. I don't now need any validation functions. I just rely on Python exceptions. So, in the previous code, I tried to prevent issues. But now I face them. I'm not afraid of them. I'm like, okay, I accept what may happen, but I'm ready to respond. So you see, I created try except statement. Of course, I put it in the loop, into the endless loop, because if user didn't type the number, I have to repeat. But if the exception was thrown here, risky line, I jump to this line and I go back to the beginning of the loop. If this line works fine, then I get out of the loop, I proceed to the second number. So, you see, my previous program was with a validator, maybe around 36 lines. Now it's only 26, and it's working the same way because I'm using system exceptions. I deal with them. I learn a new statement, try except. Okay, let's run it. Let's try. And yes, you see, my program now is stable. It doesn't crash. Why? Because I caught the exceptions. I dealt with them. When I say dealt or deal, I mean do something about it. So I printed a message and I repeated the question. So if the system sees you deal with the exception, you have something in your accept block, then it doesn't crash. So that's a more elegant solution. But here in the accept line, you may also provide the name of the exception so you can make it more specific, because right now I react on all available exceptions. Maybe it's too much. Maybe if I know what kind of exception may happen, I may provide that exception name. The other thing which is important, you may provide a second block of execution. So try except statement may have else block. And now it's kind of similar to if else statement. So you see, I have a risky block. I have the block to deal with the exception, but if the exception was not thrown or was not raised, I go to this block. So those two blocks are never executed together because this is bad case scenario, this is good case scenario. So you see, it's kind of similar to if else, because in case of the exception I go one way, one branch. In case there is no exception, I go another way, another branch. So let me show you now try except with else. So You see, now I have to have 3 blocks: risky block, exception block, no exception block, and basically also I added the name of the exception, so I made my program more specific. Now I target value arrow conversion exception only, and the logic of the program is pretty much the same as it was. So if conversion is fine, I go to else, I break out of the loop. If the conversion was not fine, I print this, and of course I repeat the loop one more time. So this version now is using try except else statement, and I'm using now precisely the name of the exception I'm trying to deal with. Sometimes maybe it's not very common situation, but sometimes you want, after those 2 alternative blocks, to have a common block of execution. So technically speaking, you may have also in try except else statement finally block. So yes, it's possible. If you want to combine something here, if you want to execute certain lines regardless of exception happened or didn't happen, then you may use finally block. But usually this version or this version, it's enough to deal with the exceptions, with the standard exceptions in your program. And the other very popular exception is related to files. I'm going to also add to my Python fundamentals tutorial or book or playlist one more lesson on files operations. And yes, they do use standard exceptions. So this knowledge is essential. You have to know how to deal with the exceptions. You shouldn't be afraid. And thank you very much. Thank you very much. As always, I appreciate your likes, your comments, your subscriptions. And stay tuned. Keep coding. Bye-bye.